How do I go about this? It's based upon a very simple calculation, which is the compounding formula, which is the formula is simply based upon a concept, whereas if 100 rupees is given to me today, rate of interest is 10%. So after 1 year, the interest will be how much? The interest will be 10 upon 100 into 100, which is 10 rupees. And therefore, this is the interest which I should receive for 1 year. And therefore, the amount after 1 year, will be the principal 100 rupees plus 10 rupees interest, which is 110 rupees. Now, there are two kinds of interest which are used in time value of money. Commonly, we use by default is compound interest, but there's also a concept of simple interest. Now, let me take an example to explain what's the difference between these two. So, let's assume on one side I'll take compound interest and on the other side I'll take simple interest. Let's say the principal starting is rupees 100 and my rate of interest is also taken as 10%. So, 100 rupees today deposited at 10% interest per annum. What is the interest for first year? The interest is simple, 10% of rupees 100, which is 10 rupees. Whereas in this case also 10% of rupees 100, the interest is 10 rupees. So after 1 year, the amount, the future value of this by compound interest will be principal 100 rupees, 10 rupees interest is 110. In case of simple interest also the same logic applies. The original principal was 100 rupees plus the interest of 10 rupees, it makes you 110. However, this is the first year. Now let's move to the second year. In the second year, the interest in case of compound interest is levied on this amount. That is, the interest for the second year will be equal to 10% of the new principal, which is the new amount, which is 110, and that is equal to 11 rupees. Therefore, the amount after second year will be equal to 110 rupees plus 11 rupees, which makes 121. However, in case of simple interest, this principal remains constant. It doesn't change. So, you always compute interest on 10% of original principal, which was rupees 100, and therefore again the interest will be 10 rupees. So, in case of simple interest, this interest will remain constant, and therefore the amount after second year will be 110 plus 10, which is 120. And that's the basic difference between a simple interest and compound interest. In simple interest, the interest will always remain constant, which is 10% of the original principal. However, which is in this case will remain 10. However, in case of compound interest, this interest will keep on changing. So, in the third year, the interest will be computed on 10% of 121, which is equal to 12.1 rupees. Whereas in this case, the interest will still remain the same, which is 10% of original principal, which was rupees 100, and therefore it will again remains 10. By default, under all circumstances, we follow compound interest unless until specifically mentioned about this. So, there are two ways of increasing the future value. One is by compound interest and the other by simple interest. In the compound interest, it's the interest is being computed on the new original amount. Whereas in simple interest, it's the interest is computed only on the original amount, which the principal does not change in any year. So, by default, as I mentioned, we always follow a compound interest concept, and in all the practical application is the compound interest is basically used. And how do I compute for each year? Well, we have a simple formula. We don't have to calculate for each year. That simple basic formula on which the future value is computed. That future value is equal to the present value, which is P 1 plus R raised to power n. So, 100 rupees deposited at a rate of 10%. So, 10% stands for 0.1. Let us assume for 3 years, this is the future value after 3 years. So, there's 100 into 1.1 raised to power 3, which should be equal to 133.1. That is the future value, which is the compounding formula based upon this. So, this is a simple way. That is, if I look at the simple example again, the future value, I can also go with the simultaneously going with the Excel functions also, so as to understand how this is applied in the Excel functions. So, in Excel function, we have a simple command which is called future value. Let me apply some examples in. So, this is my Excel sheet. So let me just enlarge this sheet which is here. Right. So let's assume the principal is 1000 rupees. The rate is taken as 10% and time is taken 5 years. How does it work? We have a command called FV, future value. The first thing the command is asking is the rate. Rate in this case is 10%. Second thing is command is asking the NPER, which is a period, number of period. In this case, it's 5 years. For the time being, we'll ignore the PMT concept, which is a payment concept. So this is, we'll ignore for 0. Then it's important that in Excel function, you should follow a sign properly. What do you mean by this? The present value and future value in this case should be in opposite sign. Why? Because if I'm looking from the cash flow perspective, let's assume 1000 rupees I'm investing in the bank for 5 years at a 10% deposit. So 1000 rupees is going out from the pocket, and after 5 years, whatever amount of money I'll get back. So the flow of money is in opposite direction. To Excel to know about this, I have to give an opposite sign. So for example, if I say today I'm depositing and this is taken as a negative sign, therefore whatever money I'll get back in terms of future value, that will come out in positive. For the time being, I'll ignore this part also, will remain 0, which is period beginning or ending will have no impact at present. So if I do this, the amount of future value is coming out to be 1610.51, which means 1000 rupees invested for 5 years at 10% rate of interest, it will amount to 1610 rupees. Now, as I mentioned, I was talking about the sign part. Let me again redo this with different signs. So future value, rate is taken as 10%, NPER remains 5, PMT ignore for the time being. Present value, this time if I take present value, this in positive sign, and type remains 0. This time my answer is coming in negative sign. Why? Because both these things are happening in opposite direction. Investment if I'm doing in minus, then the output which will come out will be in plus. If the investment I'm doing in negative, then the output will come in positive sign. And this is a very important thing when I am doing this Excel formula. So this is which is called as a future value concept. I can do many modifications in this. Let me do another modification if the compounding is not happening. Here what I've taken is the compounding is taking place on per annum basis, and the years is also in per annum basis. However, if it is not that case, I need to adjust about it. So let me go back to my presentation part here. So this is the Excel command, whereas what we've discussed about the Excel part. And let me take another example that if a person deposited 55,650 in a bank for paying a 5-year 15% interest rate return and a 10-year time deposit, how much amount of money a person will get? Let me solve this equation through an Excel. So the amount of money deposited is 55,650. So money deposited is 55,650, and the rate of return is 15%. So it make it 15%, and time is taken as 10 years. So let me change this to 10 years. So 55,650 deposited at 15% per annum for 10 years. This will become to 2,25,135.29. So this is done by using the Excel command which is there. So again, let me repeat this. I'll read out the function. Its future value, rate is taken as 15%, NPER is taken as 10, PMT is ignore, present value I take a negative sign, and type is 0. So this is the amount of money I'll receive after 10 years. So let me also take an example which is called multi-period compounding. Now what do you mean by multi-period compounding? Here the example which I have taken right now, here the compounding was happening once in a year. However, if the compounding is happening more than once in a year, it will have another concept which is called effective interest rate and the nominal interest rate. So let me take an example for this, and I'll go with the Excel part here just to explain this. For example, If instead of, let me take example, 10,000 rupees money is deposited and a rate of interest is, let's assume, 10% per annum, and time is given as, let's say 10 years. Right, so time is 10 years. Let me take how much is the future value, and we'll take all example. First, it's the yearly compounding. So this is example of yearly compounding. So if yearly compounding is done, is future value, rate is 10%, NPER is 10 years, PMT is not required at present, present value I'll take it negative, and type is taken as 0, and therefore this is the value which is here. This was done. This is a case where it is done on the yearly mode. Now let me do this if this transaction is happening in the half yearly mode. So if I'm doing this half yearly mode, let me do what has changed, which is happening, which is future value, rate. Now the compounding is taking place half yearly. Therefore what happens now is the rate will be half. So half yearly the rate will be half. However, because after every 6 months the compounding is happening, and therefore in 10 years, if compounding is happening twice in a year, so in 10 years 20 times the compounding will happen. So 10 multiplied by 2. So rate is half, time is double, PMT remains 0, present value is 10,000, and the future value is the end period is taken as 0 itself. So this is, look at the difference. Because the compounding is impacting, look at the difference, it is changing. Then if I increase to quarterly, how does it work? It is again future value, rate is 10%, but this time 4 times in a year. So I'll divide this by 4 and in 10 years the compounding will happen 4 times. So I'll multiply by 4. PMT still remains 0. Present value is 10,000. Type will remain 0. And look at the impact which you will find this. The impact is, this is yearly compounding, this is half yearly compounding, and this is a quarterly compounding. Let me do this for monthly compounding now. So monthly compounding, again future value, rate is 10%, divide by 12. Now in 10 years how many months will be there? There will be obvious 120 months, so multiply by 12. PMT remains 0, present value is minus 10,000, and type will remain 0. Oh sorry, it is 120, it should be 12. So it's 112, and therefore this is the amount which is here. So now if you look at here, as the frequency of compounding is increasing, the amount which is being calculated is also increasing. That means even though the nominal rate is 10%, but the effective rate is increasing. And therefore here we comes to another important concept which is called nominal rate and effective rate. So 10% yearly compounding, its nominal and effective will remain same. But 10% if it is compounding half yearly, what is the effective rate? So there is an inbuilt formula in the Excel which is called effective, and my nominal rate was 10% and compounding was happening twice, so it is 2, which means 10% per annum compounding half yearly is equal to 10.25% per annum. This is how it means. So nominal rate is what? It is 10% compounding half yearly. However, this is referred as an effective rate. So let me just put this effective rate I am computing. Effective rate I'll again recalculate, which is effect. The nominal rate is 10% and compounding is happening twice, and therefore the effective rate is 10.25%. If I move to the effective rate in all the 3 cases, let me calculate this. Effective rate in case of 10% per annum compounding quarterly will be effect. Nominal rate remain 10%, but this time it's happening 4 times in a year, and therefore the effective rate has gone up to 10.38%. Similarly, if I do this for the monthly purpose, then the effective rate nominal rate is 10%, compounding monthly, and therefore divide by 12, and therefore 10% per annum compounding monthly is actually equal to 10.47% per annum. So these are my effective rate. If I want to go from effective to nominal, so this was my nominal rate, this I have got to effective. If effective is known and I want to compute the nominal rates again, so this was my effective rate. So I can put like this. Let me just put control X here, control V here, and let me remove this column just to. So this was the effective rate. If I want to calculate the nominal rate once again, we even don't know the answer, but I want to just show the formula. So now the effective is known. I want to know the nominal rate. So nominal will be nominal. I know the effective rate, and this was for half yearly, and therefore it should be 10%. Similarly, here effective rate is known. I want to know the nominal rate. So nominal effective rate is known, and this was for quarterly, and therefore I got this effective rate. Sorry, nominal rate. And similarly, effective is known. I want to compute the nominal rate. So nominal will be equal to, I'm so sorry. So let me, nominal effective is given to me, and this time is happening monthly, and therefore I got my nominal rate. So we have understood in this concept that 10% per annum compounding yearly, effective and nominal both are same. It doesn't change. It's the same thing. So I've just mentioned here. Let me just put it here. So here 10% and 10%, it remains same, no big difference. However, if the compounding is increasing half yearly, 10% per annum compounding half yearly, which is a nominal rate, is equal to effectively 10.25% per annum. 10% per annum compounding quarterly, which is a nominal rate, is actually equal to 10.38% per annum. 10% per annum compounding monthly effective basically means is equal to 10.47% per annum. And it's important. So if I know somebody is saying that the bank is offering an interest rate of 10% per annum compounded monthly, and there is one bank which is offering an interest rate of 10.25% per annum, which is a better interest rate. 10% per annum compounding monthly means actually it is 10.47%, and therefore 10% compounding per annum compounding monthly is higher than 10.25% per annum interest. So it's very important to calculate what is called as effective rate, which is the real rate, which is the rate effectively the person is getting. And however, nominal rate, I can do calculations. I can divide if to calculate monthly, I can divide 10% divided by 12, which I was doing it here. I can't do this on effective. So for calculation purpose, nominal interest rate is used. However, the decision making has been based upon the effective interest rate. So in this, we have discussed two concepts. First, the concept of future value, and second, the concept of effective rate and the nominal rate. So let me go back to our presentations again. So we have discussed the concept of effective rate. This is the formula which is computed for the manual formula. We have done it through the Excel part. However, if the again this concept which applies, if it's a continuous compounding, which means we have covered maybe half yearly, we have covered quarterly, we have done monthly. However, it's happening instantaneously every second. Then in that case, what the formula will become? This will become A is equal to PERT, whereas R is the rate of return per annum, T is the time per year, and E is the exponential factor. So this is basically used for continuous compounding. Well, this function is possibly used in derivatives or maybe algo trading. Otherwise, in normal financial concept, this is not normally used. This will only be used when a compounding is taking place at a very, very fast rate. Okay, moving further, let me also do the reverse part of this, which is called as a present value. And again, let me go to the Excel part, and we will do the reverse part of this. The reverse is that this time I know that how much amount of money I will get after certain time. So I know after 5 years the future value is known to me. So future value is known to me future value after maybe 5, maybe after 10 years, I want to get 1 lakh rupees. So this is 100,000 in the year. So after 10 years, I want to get 1 lakh rupees. So time is 10 years. So let me, okay, this is time. So time is in years. So this is 10. And the rate of interest is given as 10%. Now I want to know the present values. That means how much money should I invest today? So here what is happening now, in this, let me just explain in the diagram itself. In future value, what was known? In the future value, I was given the present value and I was computing the future value. And future value was given by the relationship which is equal to PV 1 plus R raised to power n. This was the concept. However, now the present, I know the future value and I want to know this present value. So simple, what I will do this, that P is equal to FV divided by 1 plus R raised to power n. I know this. So in the timeline, this is the present part, this is the future part. Initially P was known, I was computing F. Now F is known, I am going back here. And this process, as we discussed before, this process is also called as discounting process. So let me again show this in Excel calculations, that how do we apply in Excel command. We have a ready-made command which is called PV function. So let me apply this. Present value PV, which is rate, is given 10%. Time is given as 10 years. Again, sign has to be important. If I want the present value in positive, I have to take future value in negative. Therefore, this, okay, first of all, ignore the PMT, but we'll discuss that subsequent class. And future value is known to me is 10,000. This is what I want. Type, I can take anyone, doesn't make a difference at this point. And therefore, I got 38,554 rupees, which means if I invest 38,554 rupees today for 10 years, rate of interest is 10% per annum, I'll get future value which is 10,000 rupees. So 38,554 rupees today and 1 lakh rupees 10 years after. If the return is 10%, they are both equal amount, right? And this is what the concept of time value of money is. We'll discuss this subsequently about annuity in other class.